this video, we're going to add and subtract radicals. Let's start by reviewing simplifying radicals. We did a lot of this during first semester, but we just want to take a moment and review that. So one method you could use for simplifying the square root of 27 is a factor tree. We also showed you upside down division. It's your choice. I'm going to go ahead and do upside down division over here though. Take the 27 and break it down. Prime number is 3 times 9, and break that down, which is 3 times 3. And that shows me I have a pair of 3's that go on the outside, and I have a single 3 that stays on the inside. So as far as the numerical part, this is going to be 3 radical 3. Now, I have variables in here, so I need to figure out how many pairs I have. So my A has 8. 1, 2, 3, 4, 5, 6, 7, 8 A's. So how many pairs are there? 1, 2, 3, 4 pairs. So that's A to the 4th. So when I rewrite this now, 3's on the outside. A to the 4th comes on the outside with that. Then I have B's. I have 3 B's. B times B times B. So I'd say how many pairs are there? Well, there's 1 pair of B's with 1 left over. So the 1 pair gets to go on the outside. The 1 that's left over is going to go back on the inside with that 3 that I had from earlier. So this is my final answer. 3 times A to the 4th B times the square root of 3B. And that's the full answer there. Okay. Let's look at another example. So I have inside the radical, I have that 20, so I'm going to take the time to go ahead and break down the 20. So 2 times 10, 2 times 5, got down to the prime numbers, so I have a pair of 2's with a 5 left over. So this becomes -3 times my pair of 2's, and then I have a 5 left on the inside. So we'll come back to that in just a minute. Let's go ahead and look at our variables first. I have m to the 9th. So how many pairs are there? Well, I have 4 pairs. So that's m to the 4th with 1 m left over. So if I do this now, I have 1 m left over on the inside. And then I have an n to the 10th. So how many pairs are there? There's going to be 5 pairs, so that's n to the 5th. So the final answer when I multiply these together is -6 m to the 4th, n to the 5th, and then I have the square root of 5m left on the inside. And that's my final answer for this one. So there's our simplifying. So now let's extend this out to the idea of adding and subtracting radicals. So we'll slide down. Here we go. Okay, so when you're working with adding and subtracting radicals, it's just like having like numbers, like terms. So when I look at problem number 3, we see 8 radical 3 plus 11 radical 3. Well, what my brain is really doing is it's visualizing that as 8x plus 11x. So if I gave you that problem, you would easily be able to tell me that you would just add the 8 plus the 11 and get 19x. Notice the x didn't change. The same thing is happening here. This radical 3 on both of these, that's like kind of like the x piece. So all we have to do then is add the coefficients. 8 plus 11 is 19. And then the radical 3 doesn't change. It just stays exactly as a radical 3. And that's the answer. Same thing with the next one. I have a 2 radical 10 minus 6 radical 10. So since those radical 10s are the same, I really just care about the 2 and the minus 6. 2 minus 6 is -4. And then the radical 10 stays inside and does not change. Okay, and then number 5. So number 5, I have a whole bunch of radicals. They're all different on the inside. So the first thing I need to do is actually simplify each of them. So let's go through and break these apart. So I'm going to do upside down division on this. 75 breaks down. It's 3 times 25, which is 5 times 5. So I have a pair of 5s go on the outside, and the 3 stays inside. So that is 5 radical 3. Okay, let's do the 20. We just did this actually, but we'll do it again. 2 times 10, 2 times 5. So I have a pair of 2s. This time the 5 stays on the inside. Oh wait, what do I need to do with that pair of 2s though? I need to go ahead and multiply it back up here with that -6. So that gives me -12 radical 5. Oh, 363. We haven't seen that before, but it looks like 3 is probably a factor of that. So let's go ahead and divide by 3. Gives me 121. I recognize 121. That's 11 times 11. So that gives me my pair of 11s with a 3 left over on the inside. This time the negative comes down. So -11 radical 3. And then lastly, when I see this +7 radical 5, there's nothing I can do to simplify that. So it stays exactly the same. So +7 radical 5. Now, look closely at what we have left here. If you look at how I color-coded these, notice I have radical 3s on some of the terms, and I have radical 5s on some of the other terms. So those are like terms. It's like having x's and y's. So the radical 3 terms, those get added together. So that becomes -6 radical 3. 5 minus 11 is -6. And then the radical 5s get added together. So -12 plus 7 is -5 radical 5. And in the end, all of that together is my final answer. -6 radical 3 minus 5 radical 5. That's the final answer. So as you're working with adding and subtracting, make sure that you treat them like terms. The radicals inside have to be the same, and you're just adding and subtracting the coefficients.